So doing 3 or 4 or 5 partition points is easy enough to do by hand, but suppose I wanted to do a better partition, get a closer answer. If I wanted to do like 40 or 100 little skinny rectangles, can we make the calculator do things like this? And how do you set up the notation to make it add anyways, instead of writing every term out? So that's what we're doing in this part of the exercise. The actual doing things on calculator stuff I am leaving for a handout, which you should have. So I'm going to sort of sweep over that. But for right now, I want to just start by getting the general formula for any function f and any interval, and then on the back we'll make a specific example. Okay, so, and on the handout, there's in the back there's a little cheaty way to figure out what the answer ought to be, so that you can check the typing into your calculator, because there do end up being some stupid numbers of parentheses if you're being careful. Okay, so first, draw the interval from A to B. Oh, I'm going to do this again. The interval from A to B. So we've got A, B. The total width is B minus A. So the total width from 3 to 5 is 2, because it's 5 minus 3, for instance. Width of each partition piece if we're breaking it into n many pieces, okay, so is going to be B minus A over n. Now, the first thing that people screw up is, if you go over to the first right-hand endpoint, it is not B minus A over n, it is A plus B minus A over n. Okay. And then if I do another little bunny hop of one width, that's going to be still just A, and then 2 bunny hops. So this is B minus A over n. This is also B minus A over n. So. Okay, so now we're going to use some notation, and I'm going to figure out a general ith endpoint. Notice that I can take this left endpoint as A plus 0 B minus A over n's, if I want to do it that way. The ith right-hand endpoint will be A, the bottom of the interval, plus I many B minus A over n's. And the ith right-hand height, you get the height by plugging into the function. So it'll be f of A plus I many B minus A over n's. Okay, and as I goes from 1 to n. So when we do the sigma notation, the bounds will be I going from 1 to n. If you do the left-hand endpoint, it'll be, you need to start with the 0th B minus A. You need to start at A, so we have to adjust I. You can see where the parentheses start to add up. Fortunately, b minus a over n is a number, so that doesn't need its own parentheses when you start typing it in. Now with series, you can have a bounds that don't have to go from 1 to n. You could go from 0 to n minus 1. So that's something. Then what do? You just use the same notation as with the right-hand endpoint. Okay, so that's a special, that gets us the left-hand endpoint for almost free. The middle one is tricky no matter how you do it. So notice that the middle what's in the middle between I minus 1 and I? We'll use I minus a half. So the endpoint is going to be a plus I minus a half mini b minus a over n's. So the midpoint sum height is going to be f of that. Okay, and then the sum of the rectangles, don't forget the rectangles are height times width, not just height. Remember, b minus a over n is a constant, a number. So I'll just write down the three formulas. The sum, right-hand numbers, is going to be the sum I going from 1 to n of the heights. Don't forget the a plus. I mini b minus a over n's. Don't forget to multiply by the width. Okay, and then the left. I guess I should put parentheses around the b minus a over n's. You don't need it in the notation, but you do need it if you're typing it into your calculator. You should be b minus a over n is a number anyways, so you should be simplifying it down to a single number. And then the midpoint, you have to go back to the old standard I going from 1 to n. Okay, finally, an example. So the width is b minus a over n. A is 1, b is 3, So 3 minus 1 over n. So n is 40 in this first thing. So I've been inconsistent in my notes about whether I want to write 1/20th or 0.05. Doesn't really matter. It's better as a fraction if it's not a terminating decimal. If it's a repeating decimal, don't turn it into a decimal. So the ith height A is 1 in this problem. Okay. A isn't always 1, be careful. A is whatever the lower bound is. I times 1/20th is just I over 20. Stuff that into the function f of x. Notice here's f of x. So thingy squared plus 4 thingy. What do we got? 1 plus I over 20 being plugged in. Okay, so it's the sum extra parentheses. I'm going to color code them in a minute. Actually, let me color code it right now. This outer parentheses has to get multiplied by the width. And the inner parentheses is the function itself. So okay, so when you type it into the calculator, you have to be really, really careful. Make sure that also people put i's on the outside. That's a 1. It's not an I. The width is constant. It doesn't have an I in it. Follow the directions on the supplemental handout that tells you how to type things into the calculator. If you do it right and you get the right number of parentheses, you should have sum of, it forces parentheses, sequence, it forces more parentheses. Then this is what you type into the expression. Problem, we've got even more parentheses. So let me just, the sequence parentheses I'm going to mark in green. We still need the blue parentheses. Yes. And then times 1 over 20. And then the variable, you have to type what variable you're going to be using, and the bounds. And the step, and I talk about the step in the handout also. So this is the close the sequence parentheses, and then let's even do more colors. Parentheses here. So notice you need just to make sure you understand, this, when you get to your calculator, this all is what comes under expression, EXPR. So be careful with that. That's going to be the hardest thing on this whole paper, is to make sure that you get the stupid parentheses right. Okay, so the left-hand height, it's going to be you'll do it properly first. This is the formula from the other side. So it's f of 1, a is 1 in this problem. Extra parentheses around I minus 1. And you'll have to do that anyways because you have to divide the whole thing by 20. So when you're typing it into your calculator. You don't need it for the notation here, but you do need it when you're typing into your calculator. Okay, so what's the sum? Extra parentheses around the whole height. Parentheses around the thing you need to square. Extra parentheses around I minus 1. Why did we need extra parentheses? Because we need to multiply by the width. Okay. Remember we had this alternate way of dealing with the left sum. You can make the bounds just go from 0 to n minus 1 instead. When you type in your calculator, and again, sequence forces parentheses. You'll need parentheses around the whole height, and then you need parentheses around the thing you're squaring. And extra parentheses around I minus 1. Close the, I'm going to multiply by the height parentheses. And then 1 to 40. Step 1. And I talk about the step in the calculator handout too. Okay, or you can make the bounds. Zero to 39. Midpoint you have to do the hard way. Okay, so close the thing we're going to multiply by width by. Okay, and then calc. This is a truly stupid number of parentheses. It's a good thing there's an easier way to do this eventually. This is like limit as h goes to 0 for the derivative. Close the thing we're going to square, parentheses. All of that nonsense is inside where x used to be. Close the multiply by the width parentheses. And then the calculator tells you to put in the variable name and the bounds. And the step. And again, I talk about the step on the other handout.